Hello students, once again you're welcome to Waidsum University. Without much ado, let's begin quickly. This is chapter 4, chapter 9, section 4. Okay, so you're welcome here. Here we'll be looking at dynamic routing protocol, but one of the types of dynamic routing protocol. Here we'll be looking at the first general type of dynamic routing protocol, which is called the distance vector routing protocol. So that's what we'll be looking at in this section. So let's quickly go through this. A very good example of a distance vector routing protocol is the RIP, that's routing information protocol. So this is a very specific example, a very specific example of distance vector routing protocol, which is called a very specific example of a distance vector routing protocol is called the routing information protocol. Now the routing RIP, not rest in peace, okay? This is a routing information protocol. Now the routing information protocol is a dynamic routing protocol, meaning it can periodically send its routing table. A router can periodically send its routing table to neighbor routers, can periodically propagate or send their routing table to their neighbor routers. So that's what we mean by a distance vector routing protocol, or what we probably call the dynamic routing protocol. So in a dynamic routing protocol, more specifically in a distance vector routing protocol, look more typically at routing information protocol. It's a type of protocol wherein the routers periodically exchange their routes by giving each other, propagating to each other the routing table that is present, the routing table that they have, sharing with other routers, neighbor routers or adjacent routers, all the routing table information that they have, the routing entries with other neighboring routers. Okay. Now RIP, which is the routing information protocol, is classified as a good example, or is known as a very good example of a distance vector routing protocol. Distance vector routing protocol. And in this case, the router uses what we call the hop count as its own metric. The metric that is being used in this case is the hop count. Hop count is the metrics that the distance vector routing protocol normally use. Okay, the metric that it uses is the hop count. There are several metrics that can be used, but the metrics in this regard is the distance vector routing protocol metric. Is the hop count. Okay. Now the hop count is simply the number of routers that the data packet will pass on its way as a data packet move from a source to a destination network. From a source to a destination network. So when we are asked what is the meaning of hop count is the number of routers that a data packet will pass through before it gets to its destination. The number of routers that a data packet will pass through before it gets to its destination is known as the hop count. Now RIP, that's the routing information protocol, permits a maximum of 50 hops, meaning the maximum number of routers that a data packet can pass through is 15. The maximum number of routers that a data packet can pass through successfully without the data packet being returned to the source router is 15. So when it passes 15, then it's still okay, but beyond this, then it will result to what we call the routing loop. If it goes beyond 15, the number of hop counts goes beyond 15, then we will have an effect known as the routing loops. An engineering effect that is known as the routing loops, Now, routing loop is when the data packet that has been sent to a specific destination couldn't get to the destination, and the data packet is returned to the original router that sent the packet in the first place. So when the packet is returned, we say to the original router that sent the packet in the first place, we say that a routing loop has occurred. A routing loop has occurred. Now here is the diagram illustrated that. Let's say a data packet is sent from router A to router B. Now router B could be like some distance away. Maybe it has passed a lot of other routers. So when it gets to 50 and the data packet still has not get to its destination, the data packet can be returned. So when a data packet is returned, a loop has been created. This form of loop algorithm has been created, meaning from here the data packet moves to a different router, and the packet is again sent by that router to the original router. So routing loops occur when a router forwards a data packet to a router that sent them back in the first place. So when a router forwards the data packets back to the router that sent them to it in the first place. So this kind of algorithm, this kind of scenario is known as a routing loop. Now let's take more specifically, let's still look on the routing information protocol. The routing information protocol and any other type of distance vector routing protocol, they send the entire routing table. You know, we've established this information often. They send the entire routing table to their neighbor routers. So this is the difference between a leak state and a distance vector. In a distance vector or RIP, the routing information protocol to be specific, the routing table is being sent at regular interval. Is being sent at regular interval to neighbor routers. The routing table or any routing entries is being sent at regular interval to the neighbor routers. This is the characteristics of a distance vector routing protocol. This is the characteristics of a distance vector routing protocol. Is that okay? Now, sometimes the routing table can be quite large. This is where the problem is. The routing table can be quite large, and the transfer of this table could consume the bandwidth of the entire network. Okay? It could consume the bandwidth. So if the routing table, meaning the information on the routing table is huge enough, then it will consume the bandwidth of the network. Now, this makes it a bit getting outdated, you know, kind of a bit. We're looking for smarter ways to route data packet without actually using this networking algorithm, wherein a given router has to propagate or broadcast the entire routing table to all the router neighbors, to all the neighbor routers, okay, to all the neighbor routers or the adjacent routers. So in this case, there is always a bandwidth challenge because the routing table could be large depending on the information on the routing table. Sometimes the routing tables from router A could be super large, such that router B, C, D, E that receives this routing table become consumed. The bandwidth of this router become consumed, or of the network become consumed. So this will bring a slow network. This will result to a slow network, and it will result to a great network challenge. And this will be a concern to any good network administrator. Okay. Because you are now faced with a problem of limited bandwidth. You're faced with a problem of limited bandwidth. Why limited bandwidth? Because the routing table has consumed the entire bandwidth of the network. Okay? And it comes regularly, very periodically, like every 30 seconds. Every 30 seconds, this happens. So you can assume, you can figure it out, you can imagine what is going on. You can begin to imagine what is going on. Every 30 seconds, the entire bandwidth is consumed. Why? Because one router has propagated or routed the routing tables to every other neighboring routers. Okay, so this is a big challenge. So to solve this, we have to look inward to find a quicker solutions rather than using this type of routing protocols. Okay, we have to find a more suitable solutions to solve or to find the routing mechanism in order to reduce or enhance our bandwidth, or to limit this bandwidth challenge that we have currently at hand. Okay, because this way we slow the whole entire network down and we result to data traffic. If we continue to route the entire routing table to all neighbor routers or all neighboring routers, then the entire bandwidth will be will be consumed, and then it will result to low speed, and then also data traffic. Now, the default time we already mentioned for exchanging routing tables is every 30 seconds. Every 30 seconds, a routing table is being exchanged by a router to neighbor routers. This results in very slow route convergence. And if there are multiple routers sharing the RIP routes, then there will be longer convergence time, because there are more routers doing the same thing, sharing all this routing table information. So there will be longer convergence time. So all of this amount to slowness, delay, data loss, data traffic, congestion, longer convergence time, and all of this amount to all these problems. So we have to figure out how to what routing protocol that are best suited for routing. Okay, so the configuration of RIP we'll do in section 5. Okay, the procedure for configuring the RIP and the version 2 of RIP, the approved RIP, will be discussed in section 5. So with this, we've come to the end of this section. Here we looked at the distance vector protocol as a type of dynamic routing protocol, and we say a very good example of the distance vector protocol itself is the routing information protocol. And we also discuss in this subsection, we discuss the routing loop. So these are some of the terminologies that we've made use of. So with this, we've come to the end of our class. Thank you very much. See you in the next class.